Hi, welcome to Nomis Academy. Today we'll be dealing with inequalities. Inequalities, how does it sound to you? Inequalities, meaning that not equal. One term not equal to the other term. Now we'll get to know some signs used in inequalities. So when I say one term is not equal to the other term, then something must tell the relationship between the two terms. Now let's get into it. The signs for inequalities. Signs for inequalities. The first sign we have here is less than. Less than is a sign for inequality. If I use the sign less than in inequalities, meaning that one term is less than the second one, or let's say the second one is greater than the first one. So for me to tell the relationship that one is greater than the other one, or one is less than the second one, I can use just less than sign. Now if I use less than sign between two terms, now one of the term will be at the right hand side, the other term is at the left hand side. So if I say what I have at the left hand side is less than what I have at the right hand side, that simply tells that what I have at the right hand side is bigger than what I have at the left hand side. Let's take for example the use of this sign in inequality. I can simply say 5 is less than 10. I believe that is correct, right? To you, 5 is less than 10. Good. So this tells that 10 as well can be read to say that is greater than 5. Now, how do we keep this less than in your memory? Can you show your hand like this? Your left hand. Your left hand actually tell less than. When you put it like this, you get to see less than. So anytime you are confused about what is greater than and what is less than, or how does the sign of less than or greater than look, you should remember that your left hand in this position is less than. Let's take the second one, greater than. Now can you see how greater than looks like? Greater than. This is greater than. So if I have a greater than sign between two terms, it tells that the term at the right hand side is greater than the one at the term at the left hand side is greater than the one at the right hand side. So we read from the left hand side to the right hand side. Now I can rewrite 5 less than 10 to be 10 greater than 5. Now you can see it now. You know, I said this term can be read from the left hand side to the right hand side. Now considering the sign in between the terms, so the first one says 5, this side says less than, so 5 is less than 10, and the other side 10 is greater than 5. So these are the two signs. However, these two signs still come with some other one that is equal sign, but at this time it cannot totally be equal but partially be equal, so that if we are saying that a particular term is equal, we will still tell that it is greater than or less than that is equal to. Let's take for example, if we have this sign, this is less than, of course. Now if I roll it down like this, taking a part of equal sign, so we now have less than or equal to, less than or equal to, less than or equal to. So I can tell that a term, let's say a number, is less than or equal to 5. So if I say x is less than or equal to 5, meaning that x could have many values, beginning from where? 5. X is less than or equal to 5. So beginning from 5, 4, 3, 2, 1, down. So this is x is less than or equal to 5. X is less than or equal to 5. So in this term, I can regard 5 to be a value of x, and then 4, 5, 3, 2, 1. That is the sign of less than. Now let's take the fourth one. Greater than with equal sign. Greater than or equal sign. If I say x is greater than or equal to 5. Now, this term is saying that the values of x that I can ever think of is greater than or equal to 5, meaning that the value could be 5, 6, 7, 8, 9, and so on till infinity. X is greater than or equal to 5. So if I will read the values of x, I will start from 5 because of this equal sign that I have with it. So x is greater than or equal to 5 begins from that tells that x could be 5, x could be 6, x could be 7, x could be 8. So these signs are signs for inequalities, and these are the signs that we'll be dealing with today. So let us get to use these signs in some terms and to tell how best we can use it. Example number 1. Example 1. Can you use sign between 4 and 3? So what do I write here? Do I say 4 is less than 3? Or 4 is greater than 3? Or 4 is less than or equal to 3? Or 4 is greater than or equal to 3? Very good. 4 is greater than 3. So I'll put the sign of greater than. So let me write it so that you will not forget. This is your less than. This is less than. This is greater than. This is greater than. This is less than or equal to. And this is greater than or equal to. So now I can read this as 4 greater than 3, which is very true. Now let's take another example. Okay, let us see what we read. 4 is greater than 3. Simple as that. Example number 2. What if we have 1 over 4 and 1 over 5? How do we get to do this? Is 1 over 4 greater than 1 over 5? Is 1 over 5 less than 1 over 4? For you to understand well, I want to take this means to explain to you. Can you simply convert this fraction into a decimal number? Because you might get confused with fraction to order them, to tell that one is bigger than the other one, except you know the actual value. For instance, let me ask you, 1 over 4 and 1 over 2, which one is bigger? Some of you, if you don't know, you might tell by the number you're seeing to say that 1 over 4 is bigger than 1 over 2, but that is wrong. 1 over 2 is bigger than 1 over 4. So to help the situation, let us convert our fraction to decimal. So 4 over 1 over 4 can be written as 0.25. Is that correct? I believe you know how to convert this. And 1 over 5 is 0.2. So 0.2. Now, which is bigger? Can you see that 1 over 4 is bigger than 1 over 5? Are you surprised? No. Something. You see the fraction 1 over 4, meaning that there is a thing divided into 4. If it to be shared for 4 persons and the same amount of thing divided into 5 and to be shared to 5 persons, you will see that those that are given to 4 division, we have larger quantity compared to those that have 5 divisions. So I can tell you that 1 over 4 is greater than 1 over 5. So 0.25 is greater than 0.2. Is that clear? Let's take another example. Example number 3. We have 0.5, order between 0.5 and 0.29. 0.29. Now you have, just like the previous one, here you have decimal point. So how do you read decimal point? Should I say 0.29 is greater than 0.5 or 0.5 greater than 0.29? So you do not read decimal from your right hand side to say, I have 9 here, then I have 4 here, 9 is greater than 4. No, don't make that mistake. You read decimal number from the left hand side. So to compare, we have 0, 0 before the decimal point, then we have our decimal point. After decimal point, we have a 5 at the left hand side, and we have a 2 at the right hand side, meaning that what we have at the left hand side is definitely greater than what we have at the right hand side. So even if what we have after 5 will be 0, right? So I can decide to write 0. So comparing 0 to 9, you say 9 is greater than what? For the fact that you need to read from the left hand side, we tell before you get to 0 that 5 is greater than 2 then we say that 0.50 is greater than 0.29. So I'll put the sign greater than. Let's take example number 4. Example number 4. Here we have 1/4 and 1/2. Just like I mentioned the other time, this is also a fraction. So do I tell that 1/4 is greater than 1/2? No. So just like we did the other time, we can simply change them to what? Decimal number. So this fraction can become decimal number 4. 1/4 can be written as 0.25, right? I believe you know this, but for those that do not know how to convert fraction to decimal, let us quickly do that by the right hand side of our board. 1/4. Just use your decimal, your division table. So this denominator will be outside, numerator will be inside. Remember, you are dividing numerator by the denominator. So how many 4 can you get from 1? That is not possible, so you write 0 here. You put decimal point. As you put decimal point, you add 0 to 1 and make it 10. So how many 4 can you get in 10? Meaning 10 divided by 4, that should be 2. And 2 times 4 is 8. If you subtract 8 from 10, you will have 2 left. So how many 4 can you get from 2? This time you don't need to put decimal point because there's a decimal point in your answers already. So what you just need to do is to add 0 to 2 to make it 20. Now how many 4 can you get from 20? That is 5. 5 times 2 and 4 give you 20. So when you subtract 20 from 20, you are left with 0, nothing to divide again. That tells that 0.25 is the perfect dividend of 4 divided by 1. 1 divided by 4. So the answer is 0.25. So this is 0.25. Then 1/2 is 0. Let's check. Let's do it together. 0.5. Let's check together. 2 here. 1. 2 divided by 1 divided by 2. You have 0. Put your decimal point here. You had 0. 10 divided by 2 is 5. 5 times 2, that will be 10. By time subtract 10 from 10, you are left with 0. So nothing to divide again. So our final answer is 0.5. Now that I have 0.5, so what sign do I put there? That means 0.25 is less than 0.5. Remember, you read from the left hand side. So I have 0, 0 before the decimal point. Now I have 2 here and I have 5 here. So if you want to make it simple for yourself, you can also add 0 to this. It does not change the magnitude of 0.5. Adding a 0 at the back does not change the magnitude. So it is still 0.50, 0.5. So 0.25 is 0.50. Reading from the left hand side, you get here and you find 2. And at the right hand side, you will find 4. Definitely you will tell that 2 is less than 5. So you can now put your sign, which is less than. 0.25 is less than 0.50. So let's take another example as regards less than or equal to or greater than or equal to. So if I say x is less than or equal to 5, and this, so for me to tell the values of x less than or equal to 5, just like I explained earlier, x would be 5, right? Less than, do I go to 6? No. For x is less than, the value here is less than or equal to 5. So if I take 5 to be the first one, other ones would be 4, 3, 2, 1, 0, minus 1, minus 2. It continues like that. So you can represent, in case the question asks you to list, you can represent it like this, and when you get to a point, you don't have to list all the numbers because it's not even possible to list all the numbers. So you just have to stop it by comma. This 3 full stop says it continues. Are you getting it now? So probably you can put comma and put the sign of infinity. So that tells that till infinity. Are you getting it now? So x is less than 5. So this can tell. There is no limit to where the value of x should stop. So we are getting we'll get to where x could have limits. Let's take for example number 6. So we have 10 examples to solve here to understand this science of inequalities very well. So let's take x greater than or equal to 5. So in this case, if I should tell the values of x, then I will begin from 5. So I'll begin from 5 greater than or equal to 5. So 5, 6, 7, 8, 9, 10, 11. If you like, you continue to 1 million, but you can just put your comma. This 3 stop to tell that it continues, comma, till when? Till infinity. So these are the values of x, or these are the values that x could exhibit. Now let's take for a limit. Number 7. If I say x is greater than 5, the same value of x is less than 10. So what are the possible values of x? So if these two must be considered such that the x still stand for the same x, so I will say that x could be, if it is greater than 5, so I'm starting from 6, 7, 8, 9. Now should I put 10? No, because the same x is less than 10. Therefore, 10 could not be x. Are you getting it now? So these are the values of x here. X is greater than 5 and is less than 10. So the values of x then is 6, 7, 8, and 9. Is that understood? Bye bye. See you in the next video.